So this is the last of the videos of probability. If I was smart or had planned things out well, I would have had some applause for you, like playing over my speakers, but I don't have that. How about this? How about just a little golf clap for making it through all of probability? Excellent. Now let's start looking at the general rules for probability. The rules of P of A and B are P of A times P of B if and only if, and we have this IID thing here. What is this? So IID is sometimes my abbreviation for independent. It doesn't matter why it is. Let's just know it is. So this is independent. Just like in that song, I-N-D-E-P. Okay. But what if they're not independent or we're not sure? Then we use a general rule. And this is a general rule. So the probability of A and B is equal to the probability of A times the probability of B given A. That's the rule. Just write it down. We'll talk about it. And as we start working through some of the problems, hopefully they'll start making a little more sense. Hopefully. And here I'm going to ask you what the probability of A given B or B given A is. If we look up here, we can divide both sides by P of A. So the right-hand side is P of A and B. That's a P, don't hate. Divided by P of A. Let me get my eraser so it looks a little more like a P, because I already heard you haters. There we go. And it also says, let's take a look at this. P of B given A is equal to P of B if and only if A and B are independent. So let's see. If we look up here, if and only if they're independent, this is true. So if we go from this rule to this rule, let's see, AA. Hey, look. Look at this here. If we substitute P of B given A for P of B, we get this top equation. Okay, I'll give you a second to pause the video and to look everything over and write everything down. And then I'll go on. More general rules. So last time we did and, this time we're doing or. We know and means multiply, or means add. If we don't, we should write that down real quick like a bunny. And means multiply, or means add. So it says here, this is the first rule, the top rule is a rule we know. P of A or B is equal to P of A plus P of B if and only if A and B are disjoint. Remember, disjoint means they can't both occur at the same time. An example of a disjoint event would be the probability the Steelers win the Super Bowl and the probability the Steelers do not win the Super Bowl. They cannot both win and not win the Super Bowl at the same time. You notice I didn't say lose. I said win and not win, because lose implies they played, and they may not necessarily play in the Super Bowl. So that's some semantics. So let's say that we don't have a disjoint event, or we're not sure. P of A or B is equal to P of A plus P of B minus P of A and B. And maybe a Venn diagram would help with this. So a Venn diagram for this, when they're disjoint, A and B, they're disjoint, there's nothing in common. Here, there's some stuff in the middle. So this is A, all this circle. This is B, all this circle. But we don't want to count everything because this stuff in the middle gets counted twice, right? So we count everything that's in A, everything that's in B, and then we take out the stuff that's been counted twice. We'll do an example like this in class so you can visually see it. But here's a Venn diagram for it. So we have my crazy math life here. The 3 dots in math actually means therefore. It does not mean my crazy life. It means therefore. P of A and B equals something if A and B are disjoint. So A and B are disjoint. What's the probability of the stuff in the middle here? I'll give you a second to do some thinking. And I'll give you the answer. The probability that you're going to get something in the middle is 0. So the probability of A and B, if A and B are disjoint, is 0. Why? Because there ain't nothing here. Alright, that's it. That's the last chapter of probability. Ask questions. Lots of questions. I'll help you with them. Love probability, but it's tricky.